right, so today is going to be the demo portion for the kind of introductory part of the course. So today we'll be finally learning some Swift. The structure of the demo, so I'll just kind of preface how these demos are going to be run before we actually start. Lecture is going to cover the content in an abstract level, and demo is probably just going to be Elvis and I kind of just up here writing code. Now, to make sure things kind of go smoothly, sometimes we will have a starter code be posted so that we don't start from a blank slate. And to kind of access that starter code, you will always post it on the course textbook. So some of you may already have downloaded this, but the idea is that the course textbook is split into weeks. If you go into the future weeks, some of the kind of recordings won't be there because it hasn't happened yet. But for this week, the kind of demo from Monday has already been, the lecture from Monday has already been posted and it is here. And the demo for today, if you scroll down a little bit, is right here. So one thing I just wanted to mention, and for those who kind of came early already heard this once, but the idea is that the Gitbook or the course textbook, which is kind of hosted on Gitbook, sometimes serves you older versions of things, right? So to make sure that you get the most updated version, I just like to kind of reload the page a couple times, and you should see d1starter.playground.zip, and the size should be 15 KB, and that is the demo of the starter code that I'll be using today. All right, so we have a lot to cover today, so we're going to actually dive straight into that. But before that, sorry, we're not going to dive straight into it. Some announcements. So first, we have been receiving some emails about people unable to enroll on Student Center. That is actually a very interesting problem this semester because this is the first time where we kind of hit more than 100 students enrolling on Student Center. And I think there probably is some soft cap at 100. So we're emailing the registrar and we're kind of talking with them right now to hopefully resolve this issue. We've had some students manage to enroll if you just click enroll a couple of times and you just get in. So that's something that you can try right now. But until the registrar responds to us, we kind of hope that you guys can be a little patient. And I mean, the deadline to add the course is October 19th October 19th. So we do have some time. And so we'll let you guys know once we get a response and hopefully everybody can get enrolled. Another thing, so we have been getting some questions about the compatibility for kind of the Xcode version as well as the OS version of your Mac. So there are some people who are enrolled in 11.10, and the 11.10 policy is do not update your Mac. Walker said that. So I kind of talked to one of the 11.10 head TAs, Gonzalo, and the idea is that we got approval for you guys. If you're in 11.10, it's okay for you to upgrade your Mac to macOS Monterey 12.6, but do not upgrade to Ventura because that may break your projects for 11.10. Whereas 12.6 on Monterey is fine. So if you upgrade and you have any issues on 11.10, you can go find Gonzalo. I checked with him; he said that's okay. And if you have any issues after you upgrade with the iOS portion, you can come find us, the core staff. Okay, cool. And finally, one of the last announcement is make sure that you're on CMS, because after today's demo, we'll be releasing the first project, and you'll need to have access to CMS in order to submit the project. Any questions about the announcements? All right, cool. So let's get straight into the demo. Oh, about that. So today, I downloaded this already, but if you downloaded the zip file and unzipped it, you should get this kind of interface set up here. So what is this? This is called an Xcode playground. And we'll actually only be using this for this week, because from kind of next week onwards, we'll be actually building apps. But for now, we want you to kind of learn how to use Swift first. And kind of low barrier of entry way to kind of mess around and play around with Swift syntax is using a playground. So I'll quickly run. Is this size okay for everyone? Can everybody see the text on the screen at the back? Cool. All right. A little bigger? Sure. Yes. So is that good? All right, cool. So I'll quickly run over what kind of the interface is, and we'll begin the demo. So the way you kind of run the code, right? So you write the code just by pressing enter, and it's just like a text editor. It's like a document. You just write on it, right? But the way you run the code is if you hover your mouse on the left and you see this little blue button. So the idea is that you see how 1 to 3 is highlighted, and I'm hovering over line 4. And if I click this button, what it does is it just runs all the lines from 1 all the way up to the button I clicked, right? So basically everything that is highlighted. So say if I were to come down here and print the classic hello world, right? And I press this, then you should see hello world be printed. And where does that get printed? It gets printed down here in the console. Okay, so that's the second part of the interface. And you can kind of ignore the right-hand side for now. It just gives you like the values of variables temporarily. But I think for the sake of this demo, I'll just be printing out things that we find interesting. So you can just focus on one, the text editor, so this part, and two, the console down here. Okay, so that's the setup of the playground. Now let's get into learning how Swift works. So yeah, so I walked through the playground interface. So I'm gonna delete this. So if you have worked with Python before, this kind of import structure up top should be familiar. If you haven't, that's fine as well. The idea is that sometimes when you write code, you don't want to just start from scratch every time. You kind of want to be basing your code off the shoulders of other giants. And so the idea is that you can import other people's code. So for example, say somebody has dealt with all like the time conversions, right? And there's this library called time. Well, if you want to kind of display the time on your app, then you don't have to work out all the intricacies across time zones. You just import their time library and you just use it. So that's the point of this kind of import statement up here. And so I'm importing this thing called UIKit. Right now, this may look like Greek to you, but next lecture, we'll be talking all about UIKit. So for now, just think about this as a very important library for kind of building the UIs of your iOS apps. Okay, so let's get into the very, very first line of Swift that you'll be writing today. So first, I want to kind of talk about variables, right? You may have heard that before from kind of basic algebra, like let x is equal to something. And in Swift, you can also have variables, right? It's a very core to kind of any type of programming language. But there are two types of variables. And specifically, one is called a constant, and the other is called a variable. Now, like the name kind of suggests, right? Constants cannot be changed. They're always the same, hence constant, right? And variables, well, they can vary, right? So, and the difference here is that to create a constant, you use the let keyword, and to create a variable, you use the var keyword. So var is for variables, let is for constants. Hopefully that's not too confusing. So over here, what I did is I created a net ID, a net ID constant. So it's a let constant here, and that's my net ID. And this is not the current year. So, let me just set like this for now. And we created these two variables here, right? This is a string. So a string is kind of just a bunch of characters. If you've worked with Python, Java, this should be somewhat familiar. But if you haven't, that's fine. You can think of a string as just kind of a bunch of characters joined together. And then this is just a number. Cool, but we realize, right, this year is not 2021. Today is 2022. So we can just change the year by using a kind of equality statement here. But, in math, right, you would say, current year is equal to 2022. But over here, what you're doing is you're assigning a new value to the variable, right? So the reason why I can do this is because a variable can be varied, right? We can change it. It is mutable. Whereas if I try to do the exact same thing for the net ID, so I change the net ID to, say ABC 1, 2, 3, and I try running it one more time, right? Will this work? No, right? Because as I said just now, right, the let constants, it's the value, the value stored in the variable, it stays constant. So you can't change a let constant. Okay, cool. And that is how you would be modifying a variable. So any questions about this? This is hopefully laying the bricks for kind of what is to come in the future. Cool. So moving on. Now we have variables, right? We could be, a little more strict with the way we want our variables to be, right? So say, for example, I know that my name is going to be some type of string, right? I don't want to call myself one, right? I want to have an English readable name. So I'm going to say that my name has to be of type string. And similarly, we know, right, the number month because this is going to be an integer. So we assign it a int type. And over here, we have this thing called a UI label, right? So you don't know what it is right now. You can probably guess at some form of label. But for now, all you really need to know is the UI label is also a type. And over here, this is a little unfamiliar, but it's fine because what you're basically saying here is I'm creating a label and I'm assigning it to this variable called label, and the type of this label is UI label. Okay, that's how you would read this. So like I could have set these variables without adding the type without adding the type annotations. So what is the point of this type annotation, right? And the idea is that you kind of want to make sure that your code is somewhat bug-free. And in fact, Swift kind of helps you with that. And Swift is really nice. And it is what we call strongly typed. And what strongly typed means is that when I assign a variable or a constant for that matter, a type, that type can no longer change. So let's look at this example here, right? So over here I have full name, and up here I said it is a string. So if I want to be really cool and I call myself 2, right? And if I run this, Swift will complain, right? Because I said up here my name has to take on a type of string. But if I assign it an integer, it's not going to be happy. Whereas if I assign it something like, oh, sorry, why am I typing in Chinese? I'm still typing in Chinese. What? There we go. If I change it to something, this is the Chinese quotation. If I change it to something that is still a string, then it's fine, right? Then it's fine. Cool. And the same thing for month, right? Month we said is a integer, whereas if I change it to something like a string, so like January, right? It's not going to be happy because, a string is not an integer. Okay. Now, that is like explicit typing, right? Like explicit in the sense that I like wrote specifically here that the full name is of type string. But there also is this idea of implicit typing in the sense that if you don't tell Swift what type a variable is or what type a constant is, Swift guesses it, right? So the idea here is, say I create a variable, a very mysterious variable, right? And I assign it to the value of 2. Now, since I assigned it a value of 2 and we know 2 is an integer, what Swift basically knows at this point is that, okay, the programmer kind of assigned an integer to this variable. So that means this variable must be of type int. And so therefore, if I assign it a different value, a different integer, it's like, okay, sure, right, that's fine. But if I assign it a string or something that is not an integer, it's like not an integer, then Swift is not going to be very happy. Okay? So that's the idea of typing. And we have both explicit types and implicit types. Any questions there? All right, cool. Very nice. Now, up to this stage, I've just been kind of messing around with the variables, and there's no way for you guys to know, I mean, unless that you already have learned Swift before, whether or not, like, if things that I'm saying actually are happening. And so the way to kind of test that, right, is by printing things out. And as you saw at the beginning, I printed out hello world, and we saw something come out in the in the console. That is something that you can also do with print statements. So say I have a string, I'm going to call it, I should know it. String or hello world string is equal to hello. And I can just print it out. Give it a little time, and you can see the string comes out in the console. Now, we're not going to always be using strings, right? We're also going to be using other type of variables. And just now I showed you the example of an integer, for example, right? So let's create some more variables. Let's say, int 1 is equal to 2, and then let's int 2 is equal to 3, right? A little confusing, but it's fine. Now, we have a very nice way of printing multiple things, right, in kind of the same print statement. And the reason why we want to use that is, say, for example, I'm debugging some code, right? Say I have some variable, I have some value that I'm constantly updating, and I want to see if this value is actually being updated. And so the way I can kind of print it out is just by calling print, and I want to say, okay, so int 1 is currently, right? And then I do this thing called string interpolation. What it basically is, you have a slash here, and then you have an open and close parentheses, and inside that, you can put any variable. So that is a let constant, that is a var variable. You can put that in there, and it will get printed along with the string that you had at the beginning. So over here, if I insert this, int 1, and I call my print stuff, it will say int 1 is currently 2. Right? And so say I want to modify int 1 now. So first thing first, right? I need to make sure that it's not a constant anymore. I want to make it a variable. And then I change it, right? So I'm saying, okay, now int 1, you are now going to be actually 1, right? Kind of similar to what the name suggests. And then I call, or like I run the program from top to bottom. We see now int 1 is currently 1. Okay? So that just now we go through the very basics of setting up a variable. We're talking about types, as well as how we can print things. Okay, any questions there? Cool. But of course, right, just working with variables can get a little limited. So now we're going to be talking about, these things called data structures, right? We're not gonna go too in depth in terms of like runtime and stuff like that, no, right? I'm just gonna show you like just general data structures that would be very helpful, right, with your day-to-day programming or your day-to-day kind of working and building apps. So the first data structure that we're learning here is called an array, right? This is probably the most familiar data structure that you may have heard before. You may have heard of it as lists, array lists, I don't know, whatever creative name there are. But the idea is that just have a bunch of ordered values. There are multiple ways of creating an array, right? Okay, so this is actually not supposed to be here. But these two are the two ways that you can create an empty array. And so previously we talked about typing, right? We talked about how Swift is strongly typed and how if you don't tell Swift what type something is, it will guess. So over here, right, what we're saying is that lecture numbers, right, which is a var variable, is going to be equal to an empty array, and I want to kind of create it and initialize it. So that's one way that you can kind of initialize an empty array. Another way is basically using the type annotation, right? And you basically tell Swift that lecture numbers 1 is of type integer array and is going to be empty, right? So functionally, these two lines do the exact same thing, right? But they're just two ways of kind of initializing an empty array. But what something you cannot do is var a not gonna work is equal to just an empty array like this. Because like Swift's trying to help you here, right? Swift is trying to guess the type. But if you just give it an empty array, it doesn't know what type it's going to be, right? Because you could put an integer in it, you could put a string in it, you can put your groceries in it, like you can put anything in it, right? So that's why you kind of have to either tell the type using a type annotation, or when you initialize it, you have to basically also specify the type. Now, what I had commented out just now was what I was going to do next is if you actually kind of set up the array with values in it, that's also fine, right? Because Swift is kind of can look into the array and see, well, okay, like these are integers, therefore you're creating an integer array, so that's fine. And of course, like if you want to be very explicit, you can also just add the annotation here, and Swift is more than happy to kind of receive some help from you, right? Okay, and so okay, sometimes the console is a little like slow, right? It's this. So you see how like the var not going to work is like it says it's giving me the error, but I already deleted that line, right? So of course the code is gone, so it's not going to throw an error. But sometimes you may have to clear the console. So if you go to help and you type in clear debug workflow clear console, and it disappears, right? Another, if you want to be fast, you can press Command K on a Mac, and that will also clear the console. Okay, moving on. So, right, we're talking about strongly types, right? Typing and strongly typing. The values in the array must also match the type. So over here, we have lecture numbers be of type int. That means that when we're adding numbers into the array, they must also be of type int. So one way we can add values into an array is the append function, right? And like the name kind of suggests, we have this array and we append something to the end, right? Kind of just stick something on at the end. So if I append 1 to this empty, so okay, so lecture numbers here refers to this empty array, right? And if I append an empty array into it, sorry, append the integer 1 into it, and I see what's in it right now, we can see that it has just the integer 1 in it. I'm going to comment out these print functions. So, sorry, I went kind of far. I'm going to comment out these print functions so that it's not confusing. So these are like the previous things, right? Okay. And so kind of as we're talking about typing here, if I try to append something that's not an integer, so I'm trying to append the string of 1, it's not going to like it, right? Because it's a string. Okay. So hopefully that really drilled in the idea of typing here, and just make sure that the types match up when you're writing your Swift code. Cool. So now we're moving on to kind of a more expressive way to work with a list, or work with an array. Sorry, not a list. And this is an idea of a for loop. So you can think of it as basically you walking over every element in the array and you're doing something to it, right? So over here, I'm basically saying, right, so for a number within the range of 1 all the way to 10, I'm going to do something to this number, right? So before I even kind of work with the array here, I'm just going to print it out, right? And so let's just see like what am I actually getting as num? And we see, right? Hello, okay, hello world should be gone. Where's hello world? It's here. Okay, bye bye hello world. And so we see 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And so one small quirk here that I want to address is that you can have, it kind of very similarly mimic the range syntax in Python by kind of having this less than sign to make sure that it's non-inclusive, right? So it's 1 to 10, but not including 10, right? Whereas if you have it as just like 3 dots, kind of like an ellipses, then it will be including 10. Okay. And so both of them are basically the same, right? They're both for loops, but kind of the set of numbers that you're getting are a little different. And the idea here is in this kind of line of code, what I'm doing is I'm going over the values from 1 to 9, and I'm adding this number to the lecture numbers. So we would, of course, expect that lecture numbers would be changing, right? Because I'm adding new values into it. And if I print it, you would see, right? Now lecture numbers, which initially was empty when we initialized it, right, now has the values from 1 to 9. Okay? And then similarly down here in lecture numbers 2, we already have 1, 2, 3 in it, right? But now I'm appending more numbers into it. So if I print it out, lecture numbers 2, somebody want to guess what it's going to print out? So not quite, right? Because lecture numbers already has 3 numbers in it. So the idea here is when I'm appending something, it goes to the end. So the first value I append is 1, 2, 3, and then 1, and then 1, 2, 3, 1, 2, and then 1, 2, 3, 1, 2, 3. So it's actually going to be 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So yeah, very close. And so that's kind of the idea of for loops and using and working with arrays. Okay, so there's actually like okay, I'll pause here for a quick second if anybody has any questions. But I'm just going over the high level idea of working with these arrays. And at the end of the demo, I'll kind of refer you to a cheat sheet that I had open, which shows you basically everything you can do, right? There's this thing called, for example, a stride, where like say I don't want just 1 to 10 in that order. I want like 1 and then like 5 and then like 10 and then like 15, right? I want to like skip over a couple of values. That's also possible, right? But just to kind of keep things concise, I'll be like brushing these under the blanket for now. Okay, any questions before we move on? All right, cool. It's going smoothly. I'm gonna skip over this. It's not that important. But bye-bye. Okay, so when we're working with arrays, right, we want to be able to add values, which I showed you, right? We can append values, but we also want to be able to remove values. And kind of like the function suggests, we call the remove function, right? So over here, lecture numbers, we know that we added the values 1 to 9 in it. So if I remove at 0, right, what do you think is going to happen? So my question is, right, does the lecture's number array, does it have a 0 in it? Oh, yes. You want to guess? Exactly, right? Because, and this is kind of the idea here where arrays in Swift are 0 indexed. So the first index is not actually 1, it's 0. So if I call this function here and it prints it before, so actually I should have clicked this one. It prints it before and it prints it after, right? And so we see before it's 1 to 9, but after it's 2 to 9, right? And just like, what's your name by the way? Barbara. Just like Barbara said just now, you remove the value in the first index, or to be more precise, you remove the value in the 0th index. Cool. All right. And now, so say we try to do something wicked, right? We try to create an empty array, right? And we learned about the syntax just now. And we try to remove something, remove a value at index 0 from an empty array, right? Obviously, this is going to crash, right? Because there's nothing in it, right? And Swift is going to tell you no, right? All right. Finally, we learned how to add items. We learned how to remove items. But say I just want to modify an item, right? I don't want to clear it out and add things again. And the way we kind of do that is using indexing. So as we learned just now, right? The arrays in Swift are zero indexed. So over here, I have a course instructors array that has kind of the old course instructors from last semester, right? Which is me and Noah. But say, there's a new semester, new course offering, and new instructors, right? Or a new instructor. So, we print out the old array, right? And we see, okay, this is going to be Justin and Noah, but now let's change it, right? So we index into the array and we assign a new value, right? See, this is very similar to the way kind of we're setting a variable, but on the left-hand side, instead of having a var or a let keyword, we just have the array plus the index. And what this effectively does, it goes into the array at that index and changes the value, okay? Cool. And similarly, right, of course, if you try to access something that does not exist, right? So over here, say we have course instructors, which has 2 values, but the indexes are 0 and 1. If you try to access the second index, which is kind of the third element, it will crash, right? Because it's out of scope. Okay. Right. And yeah, so add, we just try using append. Now, one very last thing, say I don't want to just add something to the very end. I want to say I have like okay, I'll just create it right here actually, but I have a array of nums. I'm just going to like 1, 2, oops, I forgot how to count and I went 1 to 4, right? And I want to add 3 in the middle here. So we have a very nice function called insert, and what it does, just like the name suggests, is we insert a value. So over here we want to insert the value 3, and I want to add it at the index of. So is this 2 or 3? Okay, let's try 2. Let's see what happens. Okay, so I'm going to clear the console again because the playground's being annoying. Cool. So let's keep going, right? So I mean, the issue just now was sometimes, right, playground can just throw you random errors. It gets confused. So you can try clearing the console and running it again. If that still doesn't work, then you quit it and reopen it. So playground is a little finicky, and which is why we're only using it for the first week. After that, we'll be actually building natively with kind of the Xcode projects, and you probably won't run into any issues like this. Okay, cool. Moving on. So we dealt with dictionaries. Oh, no, dictionaries. So we dealt with arrays. We talked about how to add values, how to modify values, how to remove values, and also how to insert values at specific positions, right? And the reason why we want to do that is because arrays are what we call they're ordered, right? Because if I want the values 1, 2, 3, 4, 5, I want it to be in that order, right? I don't want to kind of next time when I have a look at it, it becomes 5, 4, 3, 2, 1, right? I want it to be in that specific order. So now we're going to be looking at another data structure, and that is called a dictionary, right? And you may have known it as like a hash set, a hash map, sorry, not hash set, sorry, a hash map, or like some other type of kind of lookup table, right? But the idea here is a dictionary is a type A to type B kind of binding, right? So it's the idea is it comes from the actual dictionary, right? Where you look up a word and associated with that word is the meaning of that word. So over here in the dictionary, say you want to create like a dictionary of like students' grades, right? So then you would have the net ID be the key, and kind of the integer score from 1 or 0 to 100 be the value, right? It's an association of one type with another type. Okay, so kind of approaching this the same order we did just now, right? You can initialize a empty dictionary in a very similar manner, but except this time, instead of just giving it one type, you have to specify both types, right? Because remember, we're associating one type with another type. So over here, the pantry, we're basically associating the string type with the integer type. So when I'm adding something into it, right, I'm going to have the string be the key, right? So the key is something that I use to look up the value, and the value is, well, the value that's associated with that key. So let's look at the example here, right? Say I'm creating this pantry dictionary, which associates strings to integers, and the idea is it's kind of like my shopping list, right? Or like a pantry. So I have an apple in it, and say I go to Wegmans and I buy 2 apples, right? So over here, the value 2 is associated with the string apple. Now, the way you add things is actually just it's very similar to the way you modify things, right? Except that, remember how if we think back to arrays, right? Just now when I showed you an array and I tried indexing at 2 when the length of the array was only 2, right? It didn't work because there is no second index. There's only 0 and 1. Whereas with a dictionary, it won't throw you that error, right? If the key doesn't exist, it just creates it. And if it does exist, it changes it, right? Which is why the way you add and modify something with a dictionary is very similar, right? It's basically the same. And so over here, if I print it out, and I hope it's cooperating. Yes, good, it's working. I'm very happy. And so yeah, just now I printed it out and we see that the value is 2, but now after I modify it and I print it out, we see that the value is now going to be 4. 4. Okay, cool. Now, unfortunately, if you want to remove a value, the syntax is a little different. You can't just do like this and just be like nothing, right? In fact, you technically can set it to be nil, but there are like some small differences. right, with kind of setting the value to be nil. So technically, if you look up a value that doesn't exist, like banana, right, and I want to print it out, it is going to give you nil. Right, it's going to give you nil because the value doesn't exist. So you might say, right, if I want to kind of delete an item, I could just associate it with nil, and you would be correct in some settings. And in terms of like the context of this course, yes, it's the same, but I think it's also good to kind of develop good habits. And the idea is when you want to remove an item, don't set it to be nil, right? Because there could be some other mutating side effects. Just remove it, right? And the way you remove it is using the remove function, or it's called remove value, right? And you can remove it based on the key, right? Just like how you kind of add the value based on the key, you modify the value based on the key, you also remove the values based on the key. Okay, cool. So just like how just now when I created the array kind of just by adding a bunch of number or like values into it, not specifying type, you can do the same thing with a dictionary. So over here, I got a little tricky, right? I can use emojis. And so emojis are technically kind of just Unicode, and a Unicode is just like a character, and a character are just strings, right? So technically this is just a string. So over here, what I'm doing here is I'm associating a string with a string. So this is basically the same as me kind of going var emoji meaning 2 is equal to, of the type string to string, and I equal, and I just put a bunch of values in here. Okay, cool. So I can iterate over, so just now I showed you how I iterated over arrays. I can also iterate over dictionaries. And the syntax is very similar, right? You see how up here I use kind of for some number in some range here, and I'm just changing values in my array. Over here, instead of iterating over this range, I can actually also just iterate over my dictionary directly, right? So this is a part where some people might have questions, so I'll slow down just a little bit here. The idea here is you see how I have a bracket with two kind of names here, right? I'm not going to call them variables because they're technically not variables. So the idea here is that when I'm iterating over my dictionary, right, the key, which is what we're calling over here, we're assigning it to the variable emoji, and the value is associated with the word, the keyword meaning. So in here, I can use those two kind of variables or use these two keywords, and it should be associated with the respective value in my emoji meaning dictionary. So we learned about string interpolation just now. Let's use it, right? So what this is saying is I'm iterating over my emoji meaning dictionary, and I'm just printing it out, right? So if I print it out here, we should expect the emoji and its associated meaning. Okay? Any questions about this? Yes, hello.
Why would you use dictionaries like all? Like, why don't you just use two like arrays?
That's actually a very good question. So depending on the scenario, you may choose to use multiple arrays, and you may choose to use dictionaries. So one very powerful thing that a dictionary has, in which an array does not have, is the ability to associate a key to something other than an integer, right? Because in an array, if I want to look up a value, right, I have to kind of look up it based on the index. But say I'm going to use the same example of storing students' grades, right? Like, sure, a student has a student ID, right? But say the student ID gets recycled every year, people graduate, so there are a bunch of empty student IDs. So if I create an array, there's going to be a bunch of empty slots. So why don't I just create a dictionary, and I attach the net ID, which is not an integer anymore, to that student, right? So that's like a key difference between dictionaries and arrays. But of course, as you mentioned, right, it's actually also possible to create multiple arrays and just have it simulate a dictionary, and sometimes that may even be better, right? So it really is case by case, but that's a very good question. Yeah. So, and that's a very good point. I was about to bring that up, but the idea is dictionaries are unordered. So there is no guarantee in the order in which things are going to kind of happen as you iterate over. Yes. Cool. Yes, one last question. Can values be different types for different? No, right? Because we specify that it is a string to integer. So if you have kind of some string keys, but then some integer keys, the moment you try to add them in, then it's going to give you an error. Yeah. Okay, cool. Moving on. We have a lot of cover, so I'm going to keep going. And you can also, if you say I only want the value or I only want the key, then I can specify, right? So over here I said I'm iterating over the emoji and meaning in this dictionary. But instead, say I just want the keys, then I can just do emoji meaning dot keys, which will give me a bunch of the keys, and emoji will take on the value of the keys. Similarly, if I do emoji meaning dot values, then meaning would just take on the value of the kind of values stored in dictionary. Okay, cool. So now that we're done with dictionaries, we come onto the most powerful part of programming languages, which are functions. So you can think of functions as a way to kind of encapsulate or like basically reuse a bunch of code, right? Because instead of like a classic example of like FizzBuzz, if that sounds familiar, but the idea is like kind of listing out a bunch of numbers and at multiples of 3 and 5, you kind of change it, just call it fizz or like buzz, right? But if you kind of have a function that just takes in the number and returns you the string, you don't have to write like an if condition from all the way from 1 all the way to like 100, for example. So that's the reason why we want to use functions, and it's also much more powerful than that. But yeah, so let's dive straight into functions. So functions, similar to the very big theme that we've kind of talked about just now, is the idea of typing. Typing is also really important for functions. So over here, if I don't add any annotation, right, it kind of infers that the type is of void. Basically means I'm not returning anything. Wait, I'm gonna give the print statements as well. Here, bye-bye. But say I want to actually return a value, then I need to specify the type, right? So over here, I'm returning an integer, and so it takes in A, which is an integer, B, which is an integer, and it returns an integer. So this is the syntax for writing that, right? You have the func keyword, which stands for function, the name of the function, and then the kind of the name of your parameters, and then the return type with an arrow. Okay. So one thing about functions is they were called evaluated lazily. So over here, I say print something, right? But notice how if I run the code up to this point, nothing gets printed, right? And that's not because Playground crashed again, right? Hopefully. But the idea here is that functions only get evaluated when I actually call them. So now if I call print something, then something will get printed. But like if I don't call it, right, and even if I'm executing the code from like 1 all the way to 161, right, the print statement is there, but it's not being run, right? And that's because functions are evaluated lazily, which basically means the body of the function only gets evaluated once I call the function. Okay, so yes, and similarly to like the idea of creating variables, right, the returned value from the function is just a value, right? So I can associate it with a variable. I can also kind of call print on it, right? It's all the same thing. Cool. All right, so now we're moving on to a very important distinction that I want to make here, and that's the idea of structs and classes. So if you've kind of worked with objects before in any type of programming languages, then what I'm going to say here should be very familiar, should hopefully be a review. But those who haven't, this is something that you might want to pay attention to, because this is a very important distinction that I want to make, and it's a very common mistake that people make. So the idea of structs and classes, they're both used to make objects, right? And the idea of an object is, something that has like a bunch of properties. Maybe it has like can do things, right? And by do things, I mean like functions, right? So over here, I'm creating kind of an episode object, right? And specifically here, I'm using the struct. So I'm creating an episode struct, and it has the properties of say like a name and like the duration. So how long the episode will run for. And so, so over here, I'm going to create a sample episode. So I'm just going to call this episode 1. And it is going to take on, sorry, I'm just following my notes to make sure that it is the same as what everybody sees. But you see how this is very similar to like a function call, right? But what I'm basically doing here is I'm just assigning values to my struct, and it's basically creating this object for me. So after this line, right, what has basically happened is I've created an episode that has the name of constants and variables and has the duration of 10, right? It could be seconds, could be minutes, could be years, it doesn't matter, right? And one important thing is that if I just, I forget to put the duration, right, then it won't be happy, right? Because structs, you must pass in all the properties upon initialization. Now, here's something interesting, right? Because if I create another episode and I call it now functions, and it is of duration 12. Oh, sorry, episode 2. Clear the console. All right, playground. Okay, as it runs, I'll just move on, right? I don't want to waste too much time. But basically what I did here is I created another struct, and that will be for the demo a little bit later. Okay, so that was structs, right? Basically, it's a way of creating objects, right? But I must pass all the kind of properties when I initialize it. Now, when I'm working with a podcast, I don't have to kind of specify all the properties when I initialize it because I have this init function here, right? And this init function can have default variables. So for example, if I'm creating a podcast, so I do podcast is equal to podcast and as the name of intro to iOS. And I don't want to give it an episode, right? What I can do is I basically assign it a default value, which basically means that, if the person doesn't tell me what is the episodes, just use the empty list. Okay? So that's like one important distinction, right? Classes have a init function, which basically gets called whenever you create it, and you can specify little like special things in it. Whereas the struct, you must pass in all the values when you initialize it. And there's also another distinction that I want to make. No, sorry, but before we get to that, yeah, so we talked about properties, right? So we talked about giving it a name, giving it some episodes, but how do I access the properties? And then this is where we would use kind of dot notation, which basically means I do podcast, I put a period here, and then I can access any of its properties. So if I want to print out its name, I think the playground is like a little weird right now, so I'm not going to actually print it out. But the idea is that like if I actually printed it out here, you would get the name of the podcast, and you can access it using this dot notation. Right, and you see how this kind of ties back to the previous themes of like editing values, right? Where you can access the property of the class and you can change it, right? You can do podcast.name is equal to something else. Okay, cool. All right. Okay. We are a little pressed for time, so I'll be going up to 9:30, and I'll be skipping one section, which I will be posting as a separate video, which hopefully to take like 10 to 15 minutes. But yeah, sorry, I kind of went a little too slow at the beginning. So yeah, let's keep going about this little distinction, and we hopefully can stop at 9:30. Okay, so we talked about accessing properties, and we also talked about kind of the difference between structs and classes when we initialize it. But one of the most important distinctions is that values are structs are value type, and classes are reference type. And so what that basically means is that a struct is basically the same as like 3 or like a string, right? It's like we treat it as like a value. So when I see a struct, I'm basically seeing everything in the struct, which are like all its properties, and like what else, like what other functions it has. Whereas when we look at a class, we think about it as like a pointer, right? So and here, hopefully this makes the distinction very clear. But over here, I create a episode 3, and this is created using the struct method. So if it works right now. Okay, that's very cool. So if I change the value of episode 4.duration, right? We should expect that episode 3 and episode 4 are different, right? Because the idea of a value type is that I'm only changing the episode 4, right? Because I created episode 3, and then I create episode 4, but I'm basically kind of duplicating episode 3. But episode 3 and episode 4 are both separate values, right? If I do let x is equal to 1, that y is equal to x, and I change y, x should be the same. And so if I print it out, we see that episode 3 is 5, which is the same, and episode 4 has changed. Yeah, which is what we expect. However, if we do the exact same thing, but this time we're using the class, right? So over here, what we did is I created a podcast, right, which is a class, right, as we saw just now, and I created another podcast based on the previous podcast I created. What I've done here is I've created an object, and then my next variable is pointing to the same object. So when I try editing kind of the name or changing the property stored in podcast 3, it's also changing what is stored in podcast 2 because they're pointing to the same object. So after this mutation, we should see that both of them should have the name newer podcast, right? Whereas previously it was new podcast. So if I remove this mutation, it should be new podcast. Okay, cool. So enums and cases is what I'm going to skip over. And I'm going to go straight to optionals, which is the last part. And so this is going to be pertinent to like the very last part of the project. So hopefully we can get through this pretty quickly. The idea of an optional here is that sometimes I don't actually know what value I'm going to get, right? So say I'm doing a network request, right? So I'm like, you think of it as like shouting across the art squad, and you're asking for something, right? And your friend takes a while to hear your response and then kind of yell something back at you. But in the meantime, you don't actually know what they're going to say, right? So the idea of an optional is that sometimes you just don't know what a value is going to store. And the way we kind of specify an optional is we use this question mark syntax. And what this basically allows us to do is we can store like a I don't know value in it, right? And that is kind of, as I showed you just now, is what nil is for. So if we try setting a value to be nil, if I don't use an optional, right? So over here, in fact, Swift doesn't even let you do that. But the idea here is that, see, I'm missing this question mark here, right? And so right now, the input string is just a string. Whereas if I add this question mark, now it is a optional string. And so now I can assign it a value of nil, right? And it's basically the idea of I don't know just yet, right? Okay, cool. So that's optionals, right? But what gets kind of tricky is the way we access a value in an optional. So there are 4 ways, right? I'm going to kind of go through each all the ways, and then we'll wrap it up with a Kahoot to track attendance. So the idea of unwrapping an optional, you can think of it as kind of like taking a value out of a box. So we have a box, right? Inside it, we don't know. It's like a Schrodinger's box, right? It could be something in it, it could not be something in it. I don't know, right? So I'm going to skip over this because this is not a good way, right? But the idea of this comment is just to show you that this is possible, but it's not a good way of doing it, right? You're kind of just like ignoring the fact that it is an optional and you're just like accessing it directly. But a Swifty way, right, or like a way that we kind of promote in Swift is using what we call an iflet. And the idea is that it kind of reads what it like means whatever it says here, right? It's like if the value in kind of unwrapped string, sorry, wait, what? Optional string? Oh yeah, sorry. If if this optional stores a string, then I will assign it to the value of unwrapped string, right? If it doesn't, then like the if statement doesn't get triggered, right? And so this is good because like I only want to operate on an optional if it stores a value, right? Because if it doesn't know what it's going to be at, I'll just like wait for a bit, right? So that's the idea of an iflet, right? You have like the bulk of your functionality be inside the if statement, and so only if the optional stores a value, then I will assign it to this unwrapped string variable, and then I'll work with it, right? So over here, I'm assigning the optional string to actually being a string. So that means, there is something in it. So if I run this code, it should say the value wrapped in the optional is hello world, okay? Whereas the counterexample here would be, say, it is nil, then, over here, this if statement won't get triggered, right? And print statement just won't come out. Okay, so that's the idea of using an iflet. And a guardlet is kind of the opposite, right? The guardlet is basically saying, well, right, if the optional stores a value, then I will assign it to the unwrapped string, and I will kind of jump out of this case, right? And I'll just keep going, right? So the idea is with a guardlet, so the idea with an iflet is that you would be accessing the value within kind of the conditional, right? Whereas with a guardlet, you'll be using the value outside the conditional. And so over here, if I say, if I call unwrap on nil, then I won't actually be running what's inside here, right? Because it kind of jumps out, right? Because it's not actually the optional. Whereas if I call it on something that is an optional, then it will actually use the value. Okay, so I don't want to go too much over time. So I will cover both the switch statements and the optionals in a shorter, in like a separate video, and I'll post that on Ed. Now I'll move on to the Kahoot, and then I'll give some announcements. Sorry for going over time. Try not to have that happen anymore. But yeah, let's start with the Kahoot. Yes. Okay. So as we're waiting for this to go, so project 1 is out. You can access it on the textbook. If you go to chapter 1, you scroll down a little bit, you should see the project. The project is kind of basically very similar, very similar to what we did today, right? You'll be working on a playground, and then you'll be using, some variables, creating, setting some values, right, in Swift. Okay. So as everybody joins, I will. Where's my calendar? Okay, sorry, wait, you guys need to see this, right? But yes, so the project will be due on Monday, and some days, whatever applies, we will have office hours every day up till the project is due. Tomorrow we will have one office hour by tomorrow is Thursday, which is Jennifer. On Friday we have an office hour by Alden. On Saturday we have an office hour by Elvis and Tiffany. On Sunday's the day we don't have an office hour. And Monday you would have my and Tiffany's office hours. Now you can access the office hour using the calendar, which I showed you on the textbook, and you can also look at the times on there. So I think some of them will be held on Zoom, but the link you can find on Ed. We'll make an announcement for that. Okay, cool. So I think most people have signed in. We will start. All right. Oh, the sound's not working. No. Right, very nice, right? Vars are mutable, vars are variable, that's are constants, so you can't change it. All right. All right, good job, KS2238. Also, I realized I forgot to show the leaderboard on Monday. My bad. I'll make sure I'll show the leaderboard today. Very nice. Remember the idea of kind of value types and reference types, right? So over here, I'm creating task A, which is a struct here. So I create task A, that's task A. And then I create task B, which is a duplicate of task A. So if I change the value of task B, task A should be the same, right? It shouldn't have changed. Okay. So I think there are 4 questions in the Kahoot, but the last question is about optionals, but we didn't finish optionals. So this is actually the last question. The next question I'm just going to skip over, okay? All right, so now we change task to being a class. What will I be printing here? Okay, so let me quickly explain this, right? The idea here is that when I'm changing the value of a class, right, they're basically both the same thing, right? They're pointing to the same value. So when I change kind of the second pointer, I'm also changing what the first kind of pointer is pointing to. So by changing it both to be by food, by changing it to be by food, both of them will be printing by food. Okay, cool. I'll skip over this one. So yeah, don't answer this one. Don't answer this one. This is about optionals. Okay. Someone was really fast, huh? All right. Well. So, all right. Good job, WW. Next. Oh, so it's not the person. Okay. So, congrats. Again, sorry for going over time. We'll try not to have that happen again. I'll be releasing an announcement with kind of how you access office hours, the leftover stuff, and kind of where you want to be submitting project 1. Okay? Thank you for coming.